The three main methods that we have are a data map, a tag, or a label. And I'll explain exactly what each one of these are. So a data map is essentially a treasure map of where your sensitive information is found. So if you have a PCI project and you have to do a data at rest scan and you have to pass an audit that proves where all of your PCI data is located, maybe what you're going to do is you're going to run a data at rest scan and you're going to scan your network share or your file systems, and you're going to look inside and you're going to inspect the content of each one of these files. And then what a data map does is it doesn't alter the file, it doesn't label the file. What it actually does is it creates a map, which is essentially like a treasure map here. And it says, okay, file A was found to have PII within it. And file B was found to have PCI within it. But it doesn't record anything for file C because file C wasn't found to be sensitive. Now, if you need to pass that audit, what you provide to them is the map of where your sensitive information is found. So we want to measure both persistence here as well as breadth for each one of these. So a data map has pretty good breadth, right? It's still reliant upon content inspection. So it can't readily identify images and videos and CAD files, that sort of thing. But in terms of persistence, it doesn't have any real persistence. And what that means is that if I take file A here, and if I make a copy of this, or if I do a save as operation, such that I'm creating a new file with a new name and new hash, right? Now I've got this file D. File D is no longer in my map. So there is no persistence here. I would need to run another scan in order to pick up D here and have that marked as PII. But those scans don't occur constantly, right? They can be scheduled nightly, but oftentimes these are scheduled quarterly or even yearly. So in all that time, file D is sitting here within the file system unprotected and unlabeled, and it's actually unknown whether or not that has sensitive data because it has not been inspected. So let's take a look at tags. A tag is a method for applying some sort of association to the file itself without actually marking or modifying the file. So for example, I might on file A here, I might put a tag associated with the file, but not in the file, of PII. And now whenever I copy, or if I do a save as here as file D, we're going to persist that tag. Whatever you have that's watching this file is going to automatically persist that tag over here so that file D is now also tagged as PII. Now a tag is not in the file, it's part of the file system. Typically on Windows, this is within the alternate data stream. And so this works great within a single sort of file system. Here, I've got my file system. And now the problem here though is if I have a secondary file system, let's say I've got a SharePoint repository, for example, over here. So I'll make my SharePoint. If I now copy this file from here, and I'll just call this D prime. I'm not going to make any changes to it. It's just a straight copy of this. The file itself and the data copies over, but this tag does not transfer. It's stopped at the edge of the file system because SharePoint has a different sort of file system underlying it, and it doesn't support the same sort of alternate data stream for these tags. So this tag is lost once it reaches the boundary of this independent file system here. However, tags can be applied to any type of file, right? They don't have a limitation of file extension or anything else, so it gets pretty good breadth here for a tag. We'll give it a full circle, but it has very limited persistence because it can only go within the file system itself. And then if you have labels here instead, a label is a slightly different sort of concept. So a label will actually place a change or modification within the document to mark it as sensitive, right? So I'll just mark this one here as sensitive. Now, if I have this file B here and we've marked it as sensitive, we've altered the file, we've changed it, right? It now has a slightly different hash, and this is embedded in the file. Now, if I take this file and if I make a copy, or if I do a save as of this file into, we'll just call this one E, that label will persist within that document. And then if I make another copy of this file into SharePoint, so we'll just call this one E prime. Again, that label persists into that document. So this gets a very high score for persistence here. But in terms of breadth, it's going to get just a half circle here. And that's very specifically because labels are only supported within documents that support document headers, right? And typically that's going to be your Office documents or PDFs or a few other file types. But it's not persistent or not capable of putting a label within a text document, within source code, within an image, within proprietary file formats. So if I were to take this same file here, and instead of doing a copy, if I did a save as to a CSV file or to a text file, so if I just simply took this and then put that into a text format, then I cannot put a label on this file, right? It's not able to persist that label into this new format. And now what I've got here is an unknown document, right? So it is now no longer persisted throughout the life cycle of the data, that label. So long as you keep it in specific Office or PDF formats, you're good, but once it changes, then you're going to lose that association. Now let's look at how Cyberhaven is reimagining this problem and coming up with a creative solution. And that solution very specifically is this concept of lineage. Now, the way that lineage works, because we're not reliant upon a label or a tag or a data map, what we do is we see data as it exists in your environment, as it's being modified, as it's changing, as it's moving, even if it is through a different system or a different file system or a different repository. So we see this data as sensitive, and we're not going to place anything inside of the file, right? We're kind of putting this star actually like near the file, right? So we're keeping a map of this. Now, whenever that file is changed or modified or a save as, we see that action and we're able to persist that classification to that file. And then if that file then is copied into SharePoint, again, right, we see that action and we're able to persist our lineage classification with it because it's associated with events that we've seen before. Now, if I do a save as into a text file, exact same thing, right? We can see this as that data moves. So we are following the lineage and the history, and we have the full context of the data that we can point back to and say, okay, this file here, this text file is sensitive because of its association to that original file. So because of this, we give lineage a full circle for persistence. And because it's going to be applied to any file, because we're not dependent upon the file type, we're not placing anything inside of the file itself, we're giving it full circles for both persistence and for breadth. Let's talk about content inspection. There's 4 main ways in which content inspection is typically achieved. The first of that is going to be keywords or dictionaries. So imagine that you have a file that has some content within it, right? And that content is very likely going to contain a keyword within it. So if you're working on a project, let's say you have a top secret project and that is called Project X. Now, what you can do is you can easily look through and you can look for any time that you find Project X within a document, and that will be an indicator to you that that is sensitive data and a document that needs to be protected. Now, if you're talking about something like social security numbers or phone numbers or contact information, then that's going to be a little bit harder to recognize simply based off of a keyword. So in that case, what we're going to look for is we're going to look for a social security number, which is 9 digits. That is likely separated by a dash or a space or something else. But, so you can write a regular expression that will identify this based off of the pattern, but it has to be flexible because you might also have a social security number that doesn't have any sort of delimiters within it. And now what you have is you have to have a regular expression that is encompassing of whether or not there's a dash or a space or no separator at all. Now, to make this even more difficult, you've got other information within a file, oftentimes GUIDs or other contact information or other numbers. Maybe it's some sort of GDPR or something else, right? But there are going to be other numbers within here, and you're going to end up with situations where now you have to define whether or not this is a social security number buried within this now 10-digit number. Or you're going to have a random GUID in here that just happens to be 9 digits. And while this is not a valid social security number, it will pass the regular expression for that. So your regular expression has to be broad in order to encompass and identify what is accurately a social security number, but it can't be so broad that it identifies other things, right? So you end up with this real problem of false positives. Now to combat that, there's this concept called exact data matching. Exact data matching takes this and says, okay, rather than looking for anything that looks like a social security number, I'm only going to look for my customer contact or my employee or my patient's social security number. In which case now you have a database of some sort that contains all of your customer contact information within it. And now what you're going to do is you're going to take a copy of this, you're going to provide that into your data loss prevention solution. And now anytime you're now looking within a document, you're not looking for a pattern, now you're actually looking for the exact times that there is a direct match to your customers or your employee or your patient's social security number. So this way it's much more precise, but you have to be able to statically identify this information and regularly update and maintain that list that you're now searching for. The last item over here is OCR, right? This is optical character recognition. What this means is that imagine if you didn't have a text file at all and instead this was an image document, right? Or let's say you are with a insurance company and somebody has faxed in. They've taken a picture of a document, they've sent it in to you, it's now in a PDF format. And then within that PDF is an image file that happens to contain text within it. Now what you need to do is you need to be able to extract that text from that image inside of that PDF document, and that's exactly what OCR does. Is it helps you to pull out that text and then you can perform your regular sort of pattern matching or keyword searching or your exact data matching. But all of this takes time, this takes memory, this takes CPU cycles, this takes processor power to do, and it still results in a very high rate of false positives. So the last problem here is obfuscation, right? If I have a regular expression or exact data match or anything that's going to identify that accurately, if I have this number here, 462.15406, this absolutely looks like a social security number. If I replace those dashes with X's so that I get 462XX81XX5406, none of these techniques will identify this accurately as a social security number. And that's simply because I changed these dashes here to X's. So it's very easy to obfuscate and get around this sort of mousetrap if you know how this mousetrap is built. And then the last problem you have is other file types, right? Obviously what we're talking about here is either text or it's talking about images with text buried within it. And so that's easy enough to identify. But if you're an engineering firm, if you have CAD files, if you're a media firm and you have video and you have audio files, that stuff you cannot content inspect. You cannot readily identify whether or not there is sensitive information within an engineering drawing. Nobody wants another endpoint agent, but it is necessary, especially if you're ever going to see an operation like a transfer to a USB or a print operation. You need to be down at the endpoint in order to see that operation occurring. Or if you have a user that is offline or on their home network, in order to see their activity of moving data into network shares or uploading into the cloud, if you're not on the corporate network, then you will need to be on the endpoint in order to see those operations occurring and in order to control those. So it is necessary to be down on the endpoint. Accepting that now, let's talk about how we can get visibility and what that impact does for both performance and user experience. So you have data here that is being transferred, and in some way this data is going to be transferred outside of its normal use, and it's going to be transferred into a cloud repository, a USB, or emailed, or into a network share. And so there needs to be this decision that's made, right, within this. And that decision very specifically is, do I or do I not allow this operation to occur? Now, for most legacy data loss prevention, what they do is they have to perform inspection on this file in real time. So if I perform inspection here, everybody thinks that this is quick and easy to do. But in reality, inspection does take time because underneath this is really kind of 4 different processes that need to occur. The first of that is an extraction phase. So you have extract here. And this is very specifically if you need to pull strings out of a file, or if you need to perform OCR to pull strings out of an image, this is extracting the text outside of the file so that you can actually perform inspection on it and do your pattern matching and everything else. The second part of this is that those results and those strings need to be loaded into memory, right? So now you're loading it up into memory so that you can do the actual processing, and that's the third step here where you do your processing. And you would think that this would be super simple and easy to do, but in reality there are potentially multiple engines that are being applied against that data for processing. The first engine might be for keywords and dictionaries, the second engine might be for regular expressions, and the third engine might be for exact data matching. Now you've either got to run those in parallel or in serial, right? But that will take up CPU and memory again. And then the last bit is you actually have to parse those results. So while you think that inspection is super simple to do, the reality is there are multiple processes underneath this. And this takes CPU and memory, right? You have to utilize CPU and memory of the endpoint in order to do this processing. So we'll write CPU and mem here. And this is really, at the end of the day, this is a seesaw here. And on the other side of this is time. So it will take time to extract, put in a memory, process, and then parse those results, and then return those results back into your engine, which will then determine whether or not this should or shouldn't be allowed. Now, you can do a couple of things here. You can say, okay, I want it to take less time. So if you want to drive down the time here, you can crank up the CPU and memory, right? So this is a trade-off. It can now go faster. So if you're waiting for a file to be transferred over to USB, and normally it takes half a second to do, and now with this inspection, now it takes maybe a full second. I'm exaggerating, but if it takes a full second, you can make that quicker by increasing the CPU and memory that you're utilizing. However, if you increase the CPU and memory, you're now going to impact the system performance. So while this file and this process might go through quicker, now there's a background application or a processing or a compilation that you're running that is now taking longer because you're consuming CPU and memory. On the other hand, you can say, okay, well, I'm okay with it taking a little bit more time, so I'm going to bump that up. And in return, I'm going to take less CPU and memory. Now, this makes sense, right? I can afford a little bit more time. Maybe if I'm sending an email, we're gonna hold that email before we send it out. No one's gonna notice a couple extra seconds of processing whenever you're sending out an email. And that's great. But if you're doing an upload, users will notice if there is a performance impact to that. So you have to find the right balance here in terms of time and CPU and memory and what works for your organization and how old your systems are. Okay, so how does Cyberhaven address this? Well, there's a few different things we can do. So first of all, remember that we have this concept of lineage. So if we look at where this data actually originated from on this side, maybe this data came in from Salesforce again. So knowing that it originated from Salesforce, maybe that's enough for you to say, okay, this is sensitive data because it came from a secure repository. And because of that, maybe we don't even need to do this inspection here. So if we can trust or we can identify this as sensitive simply based off of the lineage or the context or the history, then we have enough that we can skip content inspection and we can go ahead and make our decision about whether or not this should or shouldn't be permitted based off of the policy. The second part is that we can actually move this inspection up earlier in the chain. So as you were downloading the data from Salesforce, we can take a little bit more time because that data is not immediately put at risk with that operation. So now we can take our time, we can identify whether or not this is resistance sensitive, and then whenever the user later transfers that file or puts that file at risk, now we can take an action based off of not only the lineage, but also the content with inside of that. The third thing that we can do here is that we're actually going to offload this from the endpoint, and we're going to do our content inspection in the cloud. So because of that, we can crank up the CPU and memory over here. So we're going to throttle this one all the way up, right? And that's going to decrease the amount of time that we have here because we're doing all of our processing in the cloud, not on the endpoint. And this affords us that capability, right? We can throw as much CPU and memory as we want, and we get quicker time on that response. The other thing we can do is we can add in additional processing. So if we want to add in AI here, for example, that is going to look at the sentiment analysis of the actual file itself, we can now load that in because we're not taking more CPU and memory from the endpoint. We're simply doing that within the cloud, within our services. Or if we want to take a look at the AI and apply that to the lineage, so we can look at the intent of the user or the intent of where this data is associated from, then we can do that within this processing here, again, with more CPU, more memory, and cranking down the time on that.